Okay, guys, I'm just going to show you what I wrote down here. So for all three of them, do we agree that the y-intercept was 0? The c value was 0, right? There was no c value, so the c value is 0. And then remember, if you're using the gradient intercept method, you have to take your m value, which is the coefficient of x, and write that as a fraction if it wasn't already written as a fraction. So what is my m value here? What number is in front of x? It's 1, right? So 1 is the same as 1 over 1. Okay, you also could have done 2 over 2 if you wanted to, 3 over 3. I normally just put whatever the number is over 1. That's the simplest. So the gradient is 1 over 1. So guys, when I'm looking at my blue graph, when you are plotting this graph, you have your y-intercept at 0, 0. Then you count 1 up and 1 to the right. So that's 1 at the top is for up or down shift. So 1 up because it's positive 1, and 1 to the right because it's positive 1 there. So from 0, you go 1 unit up and 1 unit to the right. That is where you plot your second point, and then you connect them. Sorry, where you connect them. Okay, for the red one, for G, yep. The one of coordinates. For G, my m value here is 3, so I just wrote that as 3 over 1. You also could have written it as 6 over 2, but then you would have needed a bigger set of axes. Right, so 3 over 1. So from 0, you're going to count 1, 2, 3 up. That's the number at the top, and 1 to the right. And we plot your point there. The x value of that point is 1, the y value is 3. Just make sure that you label that as 1, 3, and not 3, 1. Okay, let's do the point 1, 3. Same thing for h. Oh, sorry. So guys, x over 2, do we agree this is the same as a half x? Right, you could have just rewritten this as half x. So your m value for that one was a half. It was 1 over 2 already. So from your y-intercept, you're going to count 1 up and 2 to the right. Okay. So from your y-intercept, which is at the origin, 1 up and then 2 to the right. And you end up at that point. Now guys, because we did have 3 graphs on the same set of axes, you do have to label them. You can decide if you just want to use the names of the functions like I did here, g, f, and h, or do you actually want to write y equals x, y equals 3x, y equals x over 2? It's up to you. No? Any other questions on these ones? All right, for number 2, there were 4 graphs. So you have to use, they said in the textbook as well, you have to use your intercept method for this one. So you have to get your y-intercept and your x-intercept, plot those two, and then connect the points. So guys, they were written in a different order here, hey? They didn't write them in the normal mx plus c order. So you could have rewritten each of them if you wanted to negative x plus 3. Right, that just, I think, makes it look more familiar, I suppose, because now you can see that your c value is 3. Guys, how are you going to find your x-intercept? By making y equal to 0, right? So you'll have 0 is equal to negative x plus 3. You move that negative x over, it will become positive x, and that's how you will get your x-intercept of 3. How do we, there's 2 questions, but like, how do we, is the one with the letter before the one in oh yes, yeah, the one that had an x. Yeah, but well, they both have x. No, so that is your x term and that's your constant term. So the term that has an x in it, yeah, is the one that has a gradient. Yeah. Guys, did anyone disagree with my intercept there? I did it very quickly and I didn't write the whole working out, so I hope, you know, they're all fine. The y-intercept, obviously, that's the easy one to find, right? The y-intercept is always a constant term. So it was 3 in this case, and 1 for the next one, negative 2 for that one, and 3 for that one. All right, so those are the easy ones. And then to find the x-intercept, you always have to make y equal to 0 and then solve for x from there. Move to the level. You can see all the points there on the graphs. All right, so they do intersect at certain points. We are going to talk about points of intersection still. Oh, I didn't label them, sorry. So my blue one was F. The red one was G. Yeah. The green one, sorry, I just want to check, was H. And then the purple one was J. Sorry, I forgot to label them. Guys, you obviously don't have to do them in different colors, right? You can just do them all in pencil and then just label with the name on the side. You also could have written the names at the top there, it's up to you, on either one of those two arrows to connect it. An X line looks like this, parallel to the Y axis, and a Y line. What do you mean? We're all done here, guys. Move back to the intersection. Alright, guys, the new heading is parabolas. And we also call those quadratic functions. So if you are done there, you can write the next heading so long. Parabolas, and then in brackets, quadratic functions.
Yeah.
Parabola. That's what's happening.
I'm just seeing the
Yeah. Okay, there we go. That is the heading, and then you can also just write down that standard form. Parabolas, yes, but I think we say parabolas. How I say. And then they are also called quadratic functions, so just in case they use that term in a test or exam or even in the textbook, then you know what they are referring to. Guys, when you're looking at the standard form, I want you to notice that there is an x squared. All right, remember the other day, I said that there is an identifying factor or identifying property, I suppose, in each equation of each type of graph, right? For a straight line, it was when it just has an x to the 1. For parabola, as soon as you see that x squared, you're going to know that it is a parabola, quadratic function. We are actually going to look at a few examples. I'm just going to pull up some graphs on here. Yes.
Because it would only be on, but it's still a parabola.
Okay, guys, I'm going to look at a few different parabolas now. I have a graphing app on here that I'm just going to show you on. Are you all done there? I'll back to it in a little while. First, we're going to look at what happens when we change the a value of the graph. Okay, so we're going to look at the most basic one, which is y equals x squared. If the equation is y equals x squared, what is our a value? It's just x squared. The a value is 1. And what is the q value then? If it's just x squared, 0. Okay, so we're going to look at the q value a little bit later. For now, we're just going to change the a value first and see what happens. So I'm going to look at, for example, y equals x squared, and then y equals 3x squared, y equals negative 2x squared. All right, we're going to look at a few of them and see what that does to the graph. Okay, so the first one that I'm going to put in here is y equals x squared. All right, that is what the graph of y equals x squared looks like. Right, so what do we notice? Where is the y-intercept of this graph? At the origin, okay? And then we see that it is symmetrical about what axis is this? The y-axis. All right. Now, guys, I'm saying that it's symmetrical because if I just zoom in a bit, if I look at the point -1 and +1, right? That point has an x value of -1 and the y value of +1. If I then look at 1, do we see that it has the same y value? All right? Now, guys, why is that? Why do you think I'm getting the same y value when I use +1 and -1? Yes, sir?
And then number multiplied by itself.
If we look at the equation, y equals x squared. All right, so whatever your x value is, you square it. So what do you get if you square a positive number? Positive. What do you get if you square a negative number? Also a positive. All right, so if I do -1 squared, the y value is 1. If I do +1 squared, the y value is also 1.
1.4 has 1.4. That 2 is about 1.4. You square 1.4, you get
It looks like
It is
it's
1.96.
yeah.
Let's look at 2. All right, 2 squared. Remember the equation is y equals x squared. So I'm looking at an x value, I'm squaring it. That will give you my y value. All right, what is 2 squared? 4. What about -2 squared? Also 4, hey? So each negative and positive x value, that's the same. Well, yeah, the same as in value, just the one is negative, the other one is positive, will have the same y value. All right, now I'm going to put in y equals, let's do 3x squared. All right, that grade one is y equals 3x squared. See that it has a similar shape. It has the same y-intercept, right? 0 again. Again, it is symmetrical about the y-axis, but now it's a bit steeper, hey? Why is that, guys? Why would the graph of y equals 3x squared have a steeper kind of slope than the one of y equals x squared? Yeah? Yes, which will give you a bigger y value. Yeah, correct. Okay, so with y equals x squared, I'm just squaring the number, that's my y value. With y equals 3x squared, like Jack said now, you're squaring the x value and then you're still timesing that by 3. So the y values are going to be much bigger, much faster. All right, does that make sense? Let's quickly look at a -1 and see what happens. Y equals negative, I'm going to do negative x squared so that we can compare the blue one with this new one.
Is the y equals like this, then y equals a. That's the like,
Yeah, so A will be 3. Okay, yeah. Right, what's happening there? We're comparing the blue one now to this is like an orange color. I don't know if you can see that. Orange on my screen. It's just the exact same graph, but it has flipped. What is the correct term if I'm talking about flipping? Reflecting, hey? It's actually been reflected in the, what axis is this? The x-axis. Do you guys remember reflections from last week? What happens when you reflect a point in the x-axis? Anyone remember? The y value is going to change, right? That's what's happening here, guys. The y value of the blue graph was x squared. The y value of the orange graph is negative x squared. Okay, we're still going to talk about reflections and so on a bit more later on, but that's actually what happens, guys. If your a value is negative, your graph is actually reflecting in the x-axis. Okay, let's do one that has a gradient. Oh, not a gradient, obviously. That has a fraction as a gradient. I'm not sure how to put a fraction in here. I'm just going to try. Maybe it's 1. Okay. No. It's not really gradient. Well, okay, I'm going to have to type in 0.5 and then x squared. There we go. So that is a purple graph. That one. Do we see that that gradient or that slope is now, what's it? Not narrower, less wider. Okay, wider. Yes, there we go.
what's the difference?
So this is a half x squared. So we've done 1 x squared, x squared, and a half x squared. Right? Because now guys, you're squaring the x value and then you're timesing it by a half, which is the same as dividing it by 2. Alright, so now your y values are actually going to be smaller. Alright. So guys, what will we say? What effect does A have on the graph of a parabola? What do we think? It changes how steep or how, let's say how narrow or how wide it is with tag narrow or wide. Yeah. And then also if A is negative, then the graph reflects in the x-axis. Okay, let's go back quickly and write that down. So now is the A the x coordinate? No, it's coordinate. What do you mean? Like, we haven't looked at x coordinate. A just has to do with the shape of the graph. Would you see how the y? We're going to talk about the y intercepts. That it makes sense as to why it's wider. And let me see. Let me figure out what my question is first. So guys, what we also say is for A, did we notice that for 3 of our 4 graphs that we looked at, the A value was positive, right? It was 1x squared and then 3x squared, and we looked at a half x squared. And then the parabola was an upwards facing parabola, right? Like a smiley face. So that is what happens. So I'm just going to write it on the side here. If A is positive, then the shape of the graph is going to look like that. Right? A positive A value. So the coefficient of x squared. Right? In a teacher exam, they might give you a letter that's not an A. All right? They can give you like a px squared or whatever. I don't know. Any other letter. A is just a placeholder for the coefficient of x squared. All right. So whatever the coefficient of x squared is, if that is a positive value, then your graph is going to be an upward facing parabola, right? Positive up, that makes sense, okay? And if A is negative, then your graph is going to look like this. It's going to be a downward facing parabola. And why is that? Because it is reflected in the x-axis. I'll just put that in brackets. Sorry, so these are 2 separate things, okay? Sorry, make sure of that. Yeah, move that. I'm gonna move it a little bit more to the side. So. Okay, now we're gonna look at Q, guys. Does anyone want to take a guess of what Q represents? Yeah?
So we use the graph up by the number 5 sides. Yeah.
Let's see what Y is. Hey, Y, the equation of the graph, guys, is actually, it's a formula. It's a formula for getting a Y value, right? For any X value. So if we're looking at this, right, we have an X squared, we have an X value, we're squaring it, and then we're adding a number to it, right? Remember that Y literally represents all the Y values on the graph. So as soon as you add like a 1 here, as soon as your Q value is plus 1, you're actually adding 1 to all of your Y values. Okay, and as soon as it's a negative 1 or whatever, you're actually minusing 1 from all your Y values. And what happens then is that the entire graph is going to either move up or move down. Okay, I'll show you now on that after, so you can also see. Okay, so where am I now? Oh, wrong one. Let's see, how do I delete these guys? Okay. The first time using this, the exponent is 0. I'm still confused. All right, so we're doing Y equals X squared again, just as our basic one, so that we can compare the others. Now I'm going to do Y equals X squared plus 1. Okay.
So the first one is just Y.
Yeah, so the plus 1 is actually going to be the Y-intercept. Yes, and then what is the X? We're going to have to calculate it. Because we can't read it all from the graph. Surely if we don't have the X,
We're getting there.
that it's going outwards. So that's the X.
That's why you get
It's just the way that they've drawn it. It's not actually.
the reason why.
Yeah, it's not actually.
Okay. That's why you get 2 answers.
Because I'm like, yes, it makes it wider and stuff. The Y is going up.
just like straight forward. Because when you're solving for x, it's gonna keep the graph straight. But you opposite, and you're so just
I don't worry too much about this graph compared to that graph. What happens here is that all of these y values are getting bigger, obviously, as we are subbing in bigger x values. And then the same thing happens on the other one. So don't stress about that too much.
Yeah, no, it makes sense though, because the distance between them in the y is the same as it just it looks like it's less because the grade.
All right, so that is y equals x squared plus 1. Let's do y equals x squared minus 3. And now I'm going to have to move down a bit. Guys, do we notice that the y-intercept for this one was 0, which was my q value? This was x squared plus 1, so my y-intercept was 1. This was x squared minus 3, my y-intercept was negative 3. Right? So guys, doesn't that make sense? Because how do you find the y-intercept of any graph? If you can't, say you forget how to find it just by looking at the equation. How do you actually calculate the y-intercept of any graph? Someone else. Yes, sure. By making x equal to 0, right? Do you remember that? The y-intercept of a graph is where x is 0. So guys, if I make x equal to 0, what is this whole term? 0 plus q, right? That will give me the y-intercept. So q is going to shift the graph up or down. But it's also going to be the y-intercept. And that is what we're actually going to plot. Okay, so the y-intercept is going to be the point 0 and q. Okay, so far we've only looked at one actual point on the graph, right? Remember, for straight line you need 2 points. For parabola, you're going to need 3 points, right, in order to draw the graph. The 1 point that you need, obviously, is the y-intercept. The other 2 points that we're going to plot are going to be the 2 x-intercepts. Okay, sometimes the graph is not going to have x-intercepts. I'll tell you what to do then. But to get your x-intercepts, guys, how did we calculate the x-intercept for a straight line graph? We made y equal to 0. We're going to do the same thing here. Make y equal to 0, and then that is going to give us a quadratic equation that we must solve. All right? So we're going to have ax squared plus q equal to 0. So guys, with the quadratic equation, we're going to have to factorize and solve for x, right? So you are going to get two x. I'll show you what to do if you don't. Okay, because I'm just quickly going to go back to the graphs that we looked at just now. Look at y equals x squared plus 1. Does that one have an x-intercept? No, hey, it just keeps going up. So guys, what's going to happen in that case is you are going to have some freedom in the whole situation. You are going to choose a negative x value and a positive x value that you're going to sub into the equation in order to get the y value. We'll do an example now. All right, so say you have y equals x squared plus 1. You know that the y-intercept is 1, but now you're trying to solve for x and you can't get an answer. Guys, if we're solving x squared plus 1 equal to 0, can we do that? In core, in AP we can, but this is not. In core, x squared plus 1. X squared plus 1, is that a difference of 2 squares? If there's a plus, no. That does not have real solutions, alright? So x squared plus 1, when we're making that equal to 0, we can't factorize it. It's not a difference of 2 squares. We'll do an example and I'll write everything down. So guys, then just choose negative 1. Sub it in, get your y value. And then choose positive 1, sub it in, get your y value. And there you go. There you have 3 points. Okay, so I'm going to write that down and we are going to practice it. So if no x-intercepts sub x equals plus or minus. Now I need to use a different letter here. I don't want to use A or Q. Shall I use B? Into the equation to get 1 negative and 1 positive.
What do you mean?
Okay. I'm gonna write something. If there are no x-intercepts. That's the whole thing that I was just discussing. Yes. And now, guys, I'm just going to add to this plus or minus b, because maybe you'll look at this and be like, what is b now? These are just two values that you choose. Okay, so of your choosing, you can decide. I always work with 1 and -1 because it's the easiest values to work with, but you can work with 2 and -2. It just can get quite big, right? The y values can sometimes get a bit big, so I think 1 and -1 would be the safest to work with, but it is up to you. Choosing even a word thing of your choice, whatever. Choosing. It sounded right when I said it, but now that I'm looking at it there, it doesn't look right. But it's okay. You can write of your choice if you want to. I won't feel offended. All right, so guys, can we practice? Any questions at this point?
So many.
All right, the first graph that we are going to do is, so just write examples. Y equals, which one shall we do? No. 2x squared minus 2. No, I mean, you can get going if you want, but I'll do it with you. So guys, now when you see this, notice that nowhere in the equation does it say draw the parabola, right? It just says draw the graph of da. So you need to see, okay, there's a squared, x squared rather, so that makes it a parabola. In the test or exam, you will get mixed graphs, right? That you need to draw. You need to know what equation is, which equation will be which graph, which type of graph. First thing that we notice is that our q value, the constant term is -2. So what is that? The y-intercept. Okay, so the y-intercept is going to be at 0, -2. X-intercepts make y equal to 0. I'm going to write here, make y equal to 0. You don't have to in a test or exam, but I'm just reminding you of what we are doing since it's the first one that we're drawing. So we're going to say 2x squared minus 2 equal to 0. Guys, is that a difference of 2 squared as it stands, as it is there? Currently? No. But what can I do with that 2? You can take it out. I can divide each term by 2, hey, because 2 goes into all of them. Okay, so what is that going to give me? X squared minus 1 equal to 0. Now, is that a difference of 2 squared? Yes. Okay, so you have two options, guys. I'll show you the other way in which you can write it just now. But it's a difference of 2 squares, so you will just factorize. So we all find that factorizing, right? Difference of 2 squares, you take the square root of x squared, goes into both. The square root of 1, and then 1 is a plus, 1 is a minus. What x value am I going to get from this first bracket if I make it equal to 0? -1, okay? So that one is -1, or from the other one, x is +1. So those are my two x-intercepts, guys. -1, 0, and then +1, 0. If you wanted to, from this step, I'll put it in red because it's like an alternative method. You can take that 1 over to the other side, and then you would have to do a plus or minus square root of 1. right? Which I'm worried that you guys might forget. So it is fine for you to do that. Then you would say x is equal to plus or minus the square root of 1, which you probably won't write down, but I'm just writing it down. So then x is plus or minus 1. Okay? So you can decide, do you want to factorize or do you want to take the 1 over? But guys, please, you have to remember that plus or minus. Otherwise, you're going to have one y-intercept and one x-intercept, and then what happens on the other side? Okay. You have to put both of them. All right, draw that graph for me, please, guys. See what it looks like. You can do that. Yeah, so now you must be careful. Now you must curve it out. Okay, remember with the sine and cos graph and tan, we have practiced that whole curving thing. All right, so I'm just going to show you quickly on this app again. Guys, you need to try and not make it like 20 here, hey? At the y-intercept, it's supposed to be around. So see if you can do that. It might take some practice. But that is the kind of shape that we're looking for. No, I know. Believe me. I understand.
No. Well, you can do either one of those. The wind relates to.
Yes.
Yeah.
Who said that?
Always was a drawing test.
You have to, but it's probably smarter to inform you. Then if you make a mistake, you can erase.
And get the further.
But we have to draw the pen and stuff.
Yeah.
To be completely honest, it's up to you, but do it in pencil because then you can. Yo, guys, now I'm even struggling. What's happening?
Got your fancy iPad just go.
No, I would think, hey? I guess I can just do it on that app, but I'm trying to suffer with you guys.
Thank you, Mama.
Thanks so much. Okay, I think that's fine. The way that I've drawn it. There, guys, remember to label your points, please. Very important. What did you say?
I will.
From me.
Wait.
I don't. What do you mean? Yep, so fine. It's no, I need to definitely need to do on whether I'm sorry whether zero was the how I'm going to do that. Streets too much about the book, okay? This is the first one that you've drawn. When you do more, it should get better, but also we're not going to be mean about it when we're talking. Look, guys, the important thing is you can't draw a straight line, hey? You can't take like a ruler and just be like, oh, I'm here about shape, I'm just going to be negative. Because that you're going to lose mark. Well, that's fine, you know. Oh, yeah. Okay. Please. We're gonna do it. Oh, yeah. We have a little. Yeah.
But all like that's my plan.
It's an app.
You're like. Josh, that's talking about.
You're on this one.
You were sorry.
Yeah, you would say it's I mean, it's not just let's be honest, but it's not just
But most of the time.
I mean, okay, let me write the whole question. Draw the graph Y equals negative. I want to do negative one. Negative. Let's just do negative x squared.
Just like.
Just negative x squared now.
No cube. Oh, 0. Thank you.
That's what you just asked for.
Yeah.
Okay, so we see
Good
that
try,
x squared. We see the x squared, and we know that it is a parabola. Sorry. Our q value is 0, yes? So the y-intercept is 0. Okay, so y-intercept is going to be 0, 0. So guys, if the y-intercept is at the origin, that is also the x-intercept, okay? Remember, we looked at that when we did straight line graphs. That's why we had to use the gradient intercept method for some of the straight lines. So now, in this case, when we try and solve for x, we're also going to get 0. Okay, we can do that, just so that you see, because maybe you won't notice immediately in a test or exam. So you're trying to find your x-intercept, so we're going to make y equal to 0. So we're going to get negative x squared equal to 0. Which is the same as x squared equal to 0. So what's x, guys? 0, hey? The only way for a number squared to be equal to 0 is if that number is 0. So our x-intercept is also 0, which is also the point 0, 0. But guys, this is similar to when I wrote that if there are no x-intercepts. Okay, there is an x-intercept, but it's the same as a y-intercept. We always need 3 points in order to draw a parabola. So now we're going to do what I wrote down here. We are now going to choose a negative x value and a positive x value, sub those into the graph, and those are going to be the other 2 points. But why am I choosing a negative and a positive point? Why not just 2 positive points? We have to have that symmetrical shape, all right? So we need the point in the middle, which is our y-intercept, and then we need a point on the one side and a point on the other side, all right? A parabola has to have that symmetrical shape. Obviously now, if we look at this one that we just drew, we have a y-intercept, we have a negative x value point and a positive x value point. All right, we have to have those 3 types of points always. Yeah.
Can you not have a parabola that's not on the y-axis? Okay.
All right, so now we're going to just sub in x equals negative 1. I'm choosing that negative 1, right? You can choose negative 2 if you want. Negative 3. But remember that whatever that number is, you're squaring it. So if you're subbing in negative 3, for example, you're going to get a y value of 9. Well, negative 9. All right? Which is going to be, you're going to have to draw your axis figure. All right. That's for you, that's fine. I just don't want to do that. So I'm going to do y equals negative 1 squared negative x squared negative 1 squared. That is my x value. What's the equation? Negative x squared.
Yeah.
What x value am I choosing? It's negative 1. So negative x squared. Yes.
No, the first square.
Yeah, the first squared, negative 1 squared is 1, but it's supposed to be negative x squared. So that point is going to be negative 1, negative 1. So that's my second point, guys. I need a third point. So since I chose negative 1, I'm going to choose the x value that is symmetrical to that one, right? So positive 1. So I'm subbing it into this equation, which is negative x squared. You don't need those brackets there. Which is also going to give you negative 1. So we have the point 1, negative 1. Guys, why am I now getting negative y values for this graph? It's a downward change parabola. Hey, what's my a value? A is negative. So it's meant to look like this, hey? It's meant to go down. So you have your intercept at the origin, and then it's going down to those 2 points. Draw this graph, please, on your own. Yeah. Start in 2 and negative 2. No, then you would get -4.
Wait, so what's the y?
Because you're squaring whatever your x value is and then times it by the minus. That's the difference. No, are you saying if you start in 2 and then what's the one putting it in here? Well, I give it x and square it. Yeah. What's the y? 0, the origin. That's what we're. Cute, we keep it. No. Or so we just is 0, you're just having to find more points there because it's 0. Okay. Who's gonna take the practice? I just chose I choose the x value and sub it into the equation to y. But now we're not using the y. You have 3, you have 3 points. The origin and the 2 that we just did.
What do you need?
Right, let's take a look. It makes sense now. I get it. Okay, there you go, guys. That's the graph. Should be like that. Mine is even a little bit pointy there, but it's fine. Hey, it's quite when I write on your face. Very important. I'm first year teaching. I saved a grade 11 function test, and I did the memo by hand. So I was so proud of the first test. You guys won't remember Mr. Marie. Does anyone know the paper video stuff? No. Okay, so he was teaching it, and he commented that's a very pointy parabola with like 3 dots, and I was so offended. But since then, I'm a bit touchy about it. It's fine.
It's fine, look at mine. Very pointy.
That is much it looks similar to mine, so yeah. All right, guys, are you ready to practice some on your own?
Yeah.
Sure.
Guys, just one last thing quickly. If you're okay, this is the graph of negative x squared minus 1. I'll do it on the board for you. Negative x squared minus 1. Is that pen of mine now? It would just move 1 down, yes, but if you don't have this one to use as like a guide, what am I feeling? Okay, I'll have to do it on here. Say it's negative x squared minus 1, then your y-intercept would be here, right? And then because your graph is a downwards facing parabola, it can't have x-intercept. If it's negative x squared minus 1, are you listening? Right? So then in that case, guys, you would also have to sub in a negative x value and a positive x value. Okay, so that is what I meant when I said here, if there are no x-intercepts. So if it's like y equals negative x squared minus 1, because your y-intercept is at negative 1, and then it must go down. It's not going to go back up to go to the x-axis. Then you must also do this thing. All right, when you're subbing in a negative and a positive x value to get those 2 points. Okay, so it's not only when your y-intercept is at the origin, it's if your y-intercept is here at the bottom and it's a negative parabola, or if your y-intercept goes at 1 and it's an upwards facing parabola. Okay, that's one that we actually looked at on that app. So just if you don't have 3 points, right? If you either only have your one y-intercept and the x-intercept is the same, or if you just have your y-intercept and there are no x-intercepts, then you have to do that thing where you're subbing.
Yeah. Never mind. Yeah, I was gonna say if the Q was like 2, then how would this work with different pieces? Yeah, if the Q was 2, then you would have, and you would have. But you never mind.
Okay, guys, you are going to do some graphs from exercise 8.3.
So is our text on parabolas?
Yeah. And the next one. So let's go to the next one. What did I say? Page 3. Oh, sorry. Page 170. And you are going to be doing number 1. Oh, it's 1 into x. Oh, okay.
Right, next.
It is easy. It's just looking at the
Are they all on the same?
No, I mean rather not, because that's very. Actually, I mean understand, but. Why we don't do that? Listen up. That is actually in this question. So let's go back up to the note at the top. They're talking about the axis of symmetry. All right. So I hope you have some space somewhere. Maybe on the side, maybe at the bottom. The axis of symmetry. Now guys, if you're thinking of an axis of symmetry, you need to figure out what line, right, would you have to fold the parabola over so that the two parts would fit perfectly on top of each other. So I'll show you now quickly on the graphs that we've just drawn. We'll go back up to that. This parabola is symmetrical about the y-axis, right? Because if I do this, whoops, it's supposed to fit perfectly. This half is supposed to fit perfectly on top of that half, all right? So the axis of symmetry is almost like the mirror line between the two halves. Does that make sense? Right? So what would we say the axis of symmetry for this one would be? The y-axis, but what if they ask for the equation of it? What is the equation of the y-axis? X equals 0, hey? Because it's a line that goes through the x-axis at 0. Every single point on this line will have an x value of 0. Okay, so the axis of symmetry of a parabola, and it's the same for all of the ones that we're drawing this year, right? Because you have your y-intercept and then the graph is symmetrical about the y-axis. So for this one as well, the axis of symmetry, or they can also say symmetry line, is the y-axis, which is x equals 0. Okay, so we're going to write that just in our note. Here's the y-axis, which is the same as x equals 0. The straight line doesn't, well, yeah, it kind of does have an axis, but I don't really want that. Well, that's not for the parabola. But next year we're going to shift into the fact, and then it will be done. Okay, but for this, yeah, it's just the y-axis. You knew what you had. Okay, we got it up, guys. We are going to discuss the whole things, domain and range, which you did say we did that with big graphs. Hey, we'll chat about that tomorrow. Someone must just remind me in case I forget. I'm sure I'll be fine. All right, that is your homework, please, guys. Get going. You still have 5 minutes. You can do the first one at least in the 5 minutes.